Welcome to today's Westpac webinar, Performance of Thermal Shipping Systems Following Distribution. My name is Roy Strunin, and I will be your moderator for today's webinar. A few housekeeping items before we start. All attendees are muted and will remain muted for the duration of the webinar. Next, let's take a moment to ensure that everyone is ready and familiar with the webinar console panel. You should have a control panel on the right side of your screen. You can minimize this panel by clicking on the orange arrow button in the upper left corner. You can expand the panel by clicking on the same button. You can submit questions at any point using the chat pane located near the bottom of the control panel. We will be answering questions after the presentation. If there are unanswered questions, we will follow up by email afterwards. For those who are registered and logged into the webinar, you can download a copy of the slide deck now. Look for it on the webinar control panel. Okay, let's get started. We are fortunate to have two very qualified presenters today. Eric Cardile is a production manager at Westpac. He began his employment in 2019 as a test engineer following an internship and graduated from San Jose State University with a Bachelor of Science in Biomedical Engineering. As production manager, Eric is responsible for managing the production staff of engineers and technicians performing customer test projects. Next, Edmund Tang is a principal engineer with Westpac and the director of packaging at San Jose State University, where he teaches and mentors up-and-coming students. Edmund is an industry expert in testing, distribution, packaging for medical, cold chain, and hazardous materials. As a principal engineer at Westpac, Edmund provides mentorship to test engineers performing package testing and technical guidance for internal and external customers. Edmund holds a master's and bachelor's degree in industrial systems engineering from San Jose State University. He's also a member of the International Safe Transit Association, ISTA, where he holds a lifetime packaging dynamics professional certification and serves on both the Certification Council and Educational Councils. I'm going to give the microphone over to the presenters who will begin the presentation now.
Thanks for the introduction, Roy. And let's begin with our webinar, the performance of thermal shipping systems following distribution. So Roy gave us a very hearty introduction already, but just in case you missed it, that's me, that's Eric. I'm Director of Packaging at San Jose State and a Principal Engineer at Westpac. And Eric is a Production Manager at Westpac. A quick overview of the presentation that we have today. So we're going to start with just introductions and backgrounds of just me and Eric, a little about San Jose State, a little about Westpac. Then we're going to talk about the project scope and thesis. And then this project actually leverages a previous project that we did a couple years ago with regards to cold chain shipments and distribution with gel bricks. So this one focuses on dry ice, but we'll get into that much later. We're going to talk about the testing conducted, talking about the data collected and results, conclusions, and possible next steps for future projects. So a collaboration between San Jose State and Westpac. This is me, Roy covered most of the items here. Been a director at packaging at San Jose State for 5 years. I've been at San Jose State for 15 years, and I've almost hit 20 years at Westpac. It's going to be 20 at the end of this year. And yes, San Jose State, we have approximately 40,000 students. We are located, the packaging department is located in the nutrition and food science department, and we currently have 60 students. And it's a small and growing program. And just a quick snapshot of how much we're growing is that in 3 years ago, we only had around 20 students. So from 20 to 60 is quite a lot. And then we have 300 students in the whole department of nutrition and food science department and packaging.
So I am a graduate of San Jose State. I actually graduated from the biomedical engineering program. Wasn't fortunate enough to be in the program with Edmund, but crossed paths nonetheless here at Westpac. I've been here for coming up on 7 years. Like Roy mentioned, just the ins and outs of all the projects that come through Westpac, you know, in charge of the workflow, the professional technical development of our staff, our test engineers and technicians as well. So been here for a good amount of time and really haven't looked back. So very fortunate to be here. little bit about Westpac and our suite of testing that we offer. Here you can see some cold chain testing that we will touch on. A lot of the testing, the transit simulation testing, we will delve deeper into in the presentation here, but we cover a lot of different industries with our testing services, as you can see here. All right, now we'll get into the actual project here, scope, and the thesis. All right, so first we leveraged the ISTA 7E standard, which outlines different temperatures that your packages will see in the distribution environment. What 7E calls out are 4 different different profiles, I guess you can call them, where they have 2 72-hour profiles and 2 144-hour profiles, and different severity levels within those profiles, a more hot and a more cold profile. So the purpose of these studies is to understand the performance of your thermally insulated package system, where you're shipping payloads and samples, your product that is particularly temperature sensitive. So you do these studies ahead of time to understand, okay, how long will my sample be at my desired temperature for, and make determinations based on that about your overall packaging system. Like I mentioned, we see different customers come through here from different industries that will utilize this type of testing service with us. We see for like biologics, vaccines, particularly like glaucoma drops, companies shipping insulin, especially food as well. We'll see anything that's going to be temperature sensitive and maybe not usable if those samples or those products go outside of the desired temperature range. So with the 7E I mentioned, it's really just like conditioning tests, meaning we're just subjecting it to different temperatures, again, that you would see in the shipping environment. Some shortcomings with that particular standard, just testing to that, is one, it's not representative of the entire trans environment, meaning any physical damages that could occur, that could happen to your package system. The 7E doesn't account for that. These are typically pristine package systems. There's no any kind of physical damage that could happen. So what we're considering here are, just some drops, some vibration, possibly compression with our study. So what we assumed, and of course this is the second round of testing second round of this study that we've done, is of course we expect the transit inputs to negatively affect the overall thermal performance of the package systems, but how much so, and what particular inputs have more of an effect than others. And of course, comparing that to our control samples to get a baseline.
All right, let's talk about our past study that we conducted in 2023. So with the previous study, we used gel bricks, and the acceptance criteria was between +2 degrees C to +8 degrees C for the product type that we need to protect. And the payload we used was an 8-ounce water bottle. So here is just a quick snapshot of the combined data in a graphical manner, but let's look at this in a number sort of way. So we have control, which is no testing, and this is our best case scenario, meaning that no testing, no drops, no vibration. Literally, these are pristine packages that have never been damaged, and is currently actually how ISTA 7E is conducted. And then what happened for one case is that we packed out in ambient conditions. So in case you don't know, or you just want to get clarification of ambient conditions, is that there's 2 ways to pack out. There's one that you can pack out in ambient conditions like a normal lab condition, or you could pack out in a refrigerated chamber. So in this case, we packed out in the ambient lab conditions, not in a chamber. And there was a very, very little degradation of just 1%. Then following the next 4 cases of extreme vibration, ISTA 2A testing, ISTA 3A testing, and then cut insulated edge shippers, we have what is known as just a little more degradation of around 2%. So still not significantly more. And then with our next case, we actually took a slotted screwdriver and we started puncturing the gel bricks, purposely making holes into the gel bricks to just simulate what happens if you have rough handling, if you just damage gel bricks. Are they still okay to use? And we punctured every single gel brick, and it only resulted in a 3.2% degradation. And then we had extreme drops, meaning that we did both ISTA 2A drops and ISTA 3A drops on the shippers. And the degradation was a little higher, I would say major degradation of 8.3%. And then finally, with the last case where we had extreme drops and vibrations. So we did everything that we can to abuse these packages. And then we had a degradation of 13.5%. So if you look at the time between a control, no testing, perfect package, it was 59 hours and 20 minutes before they exceeded +8 degrees C. And then the worst case scenario of extreme drops and extreme vibration at 51 hours and 20 minutes before it exceeded +8 degrees C. So we did this and presented it in ISTA 2 years ago. And this was the feedback from the audience. First thing that they said was that water bottles are not representative of the payload. In other words, it's just too much thermal mass. It's not realistic. So we noted that for this study. Many people asked, what about dry ice? Can you use different materials? Yes, we can use different materials. We'll evaluate that in a bit. And someone else said, do a dry ice study. And then what we talked about in the previous study, and I guess we could talk about it here, is that we didn't have a validated package, meaning that we just literally went to Uline and we just started sourcing materials and said, this looks like it's going to work. And the crowd said, it doesn't matter if you have a validated package or not. The data presented is good. As long as we know when it exceeds your acceptance criteria, this study is useful. Dry ice again. People said they loved our California vibe, meaning that Eric and I were super laid back, which was awesome. And then finally, somebody asked again, what do you think about dry ice? So we had, I think, maybe 25% or more of the people just asking for a dry ice study, which is why we're doing a dry ice study for this study. And this is just a fun California picture of me and Eric not drinking beer in a chamber, but just posing for one.
All right, now we'll get into some of the testing that we ran here. So a couple changes that we made for the second round of our study. Obviously, we're able to take a hint, not really too much of a hint, pretty obvious that people were interested in seeing how dry ice performed as the refrigerant that used. So we use that in all our test cases. And we also reduced our thermal mass. So just more realistic of the types of samples that would be shipped in this type of manner. Okay, so we're looking to obviously obtain thermal results with various variable conditions, comparing to our control condition, which Edmund mentioned. We didn't change that in our second round of study. We leveraged the ISTA 2A and 3A standards for our package performance or transit simulation tests. We did extreme cases of those two standards with drops of vibration. We varied the dry ice conditions as well as seeing how pre-damaged or damaged packaging would perform as well. Okay, so obviously we want comparable results, meaning step 1 and step 3 here were the same throughout our study. The 8 variable conditions, with the first one being our control, were the areas that we looked to compare against to change. We didn't want to change too many different things as to not get comparable results. So I'll get into each variable condition here. Just let you guys let this one sit for a second. Moving on. Okay, so a couple just items for our test that we did. Our payload was 4 milliliter vials. We had 2 per shipper. The reported data was an average of 2 data sets per variable, meaning the 2 vials per shipper. And then all test samples were exposed to lab ambient conditions for approximately 4 hours. Again, that's our controlled cases for all 9 variable conditions where we wanted to limit the amount of variability. So just taking the drops, the vibration into consideration, rather than worrying about how long the samples were exposed to ambient lab conditions. So 4 hours was consistent there. And of course, like at Westpac and in the study, all our recording devices were calibrated and per ISO 17025 and HLA standards. Okay, so our step 1, like I mentioned, consistent throughout all 9 variable conditions. We preconditioned the payload packages to -70°C. You see a picture there, representation. Okay. And along with that step 1, we packed out 20 pounds of dry ice in most of our configurations. Again, we varied that pack out condition in a few of these variable conditions. Here is a representation of the pack out, the package system that we used. Okay. And here's a video of that pack out. Okay. Okay, our first variable condition, just control, right? We just preconditioned the payload shippers and then exposed our overall package system to those 4 hours of ambient. That was the only variable, testing variable here. All right, our variable number 2 was just exactly running testing per ISTA 2A. So that includes compression, as you can see here, to 1,008 pound force, an hour of vibration per ISTA, 10 drops at 32 inches, and another round of vibration testing. Again, called out in the ISTA 2A. Our third variable condition was ISTA 3A, so drops. Difference between 3A and 2A here is we do a dynamic compression test, meaning we have a stacked vibration. You can see here in that second photo for 2 hours, and then 30 minutes unstacked vibration, followed by a final round of drop testing. Okay, then we took some extreme cases of those standards. Here with variable 4, we just took all the drop testing that ISTA 2A and 3A calls out and subjected the package systems to those drops. And all 3 bullet points there, we exposed them to. And we also combined, or not combined, we took extreme cases of the vibration profile that ISTA 2A calls out. Between 2A and 3A, 2A has the more intense, more severe vibration profile. So we subjected the package systems just to vibration here and the extreme case. Okay, our variable case 6 was just using kind of the bottom of the barrel dry ice, so not full pellets that you would normally like to see. I'm sure you would like to have. So seeing how, if can you get away with just using kind of the scraps of what you have in your dry ice supply. Okay, variable 7. So instead of the 20 pound load, we just reduced that by 10%. So here in variable 7, we use 18 pounds as compared to 20. And variable 8, a little more or a little less dry ice, 20% less than the other cases here. Okay, for our variable 9, we actually cut into the polystyrene inner shipper. At all 4 edges, we took a bandsaw to those edges just to see, again, how that compares to the rest of these cases. And of course, after all those variables, we ended with the ISTA 72-hour hot profile, and you can see that outlined here as well. And then the shippers in a environmental chamber that we have here at Westpac.
All right, let's talk about the data collected and the results we got from the dry ice test. So difference from the previous study is that now that we are dealing with dry ice, we're dealing with vaccines per many standards published online and just industry, just professionals that we talked about. We had an acceptance criteria of negative 90 degrees C to negative 60 degrees C as acceptance criteria. So as you know, as dry ice just starts to sublimate, we're going to lose more and more. And then so what we're looking for is when our packages exceed minus 60 degrees C, when it gets hotter than that. Combined data snapshot as well. So one thing that you'll notice about this graph is that there is a lot more deltas than the previous graphs, but let's look at it individually and how we classify them. So minimum effects we call for dry ice shards and extreme vibe. So extreme vibe, you look at that just from the delta, just a visual representation. We're going to add numbers to everything again. But you could say that just because the minimum effect for dry ice shards, answer Eric's questions, it's okay to use dry ice shards, it seems like. Then we have the next case where we have a moderate effect, where we had a cut EPS, where we took a bandsaw, we cut our container, and we had minus 10% less dry ice. We had a moderate effect, and just focus once again on the graphics. Numbers will come later. A major effect is when we started using minus 20% dry ice, but even more drastic than a minus 20% dry ice was just the ISTA 3A testing. And then finally, we have extreme effects of ISTA 2A and extreme drops. You could see those huge amount of deltas as well. And let's look at the numbers with regards to just the durations and actual hours. So with our T=0 control testing, the package lasted 70 hours and 5 minutes at minus 60 degrees C. The next two cases with the minor is that we had a degradation of 3.2 and 3.9 degrees or percentage with regards to extreme vibration and using the dry ice shards. Next is a little more. We cut insulated edges and minus 10% dry ice. You can see a degradation of 10% and 13%. So just right off the bat, if you remember from the dry ice, from the jailbreak study, is that we capped out around 13%. And then so right now, even at what we call moderate degradation, is that we're already at that point. Then we have the major degradation of minus 20% dry ice and ISTA 3A testing, where now our insulated shipper is being degraded by 21% and 29. And that's almost, if you look at it, 20 hours and 15 hours of just less protection. And then finally, the extreme cases for ISTA 2A and extreme drops, we're degrading 45% and 55%. So you effectively took your control shipper. If you were subjected to ISTA 2A testing, you lose almost 50% of that. The efficacy, just the ability to protect anything inside, especially if you're dealing with a cold chain shipment. So I'm going to leave that up a little longer, just so you could look at it, but way different than the jailbreak studies. And we're going to talk about why that's the case in the next few slides. But if just looking at this, you could tell right off the bat, it does matter performing these types of distribution tests for your cold chain shipments, because the degradation, at least for a shipper like this and for dry ice, is severe. Conclusions and recommendations. So conclusions, so dry ice dust shards, you're okay using dust shards, you're okay using bottom of the barrel. It has very, very little effect of your package for thermal testing. Distribution environment, now this is what we get into, where it most likely degrade the performance of the thermal shipper by 30% to 45% if it results in cracking of the thermal container. We're going to talk about that later, but just look at that snapshot really quick. We did 2 ISTA tests that is industry standard, ISTA 2A and ISTA 3A. And best case scenario for a 3A was 30%, and worst case scenario for a 2A was 45%. And definitely drops is a single most contributing factor to the thermal shipper's performance degradation if it results in cracking of the thermal container. And that results anywhere from 30% to 56%. So 30% being from 3As and 56% just being from just extreme drops of just dropping the container from ISTA 2A and 3A drops. And then so dry ice thermal shipper performance degradation due to shipping environment is much more severe compared to shipping with gel bricks, as we saw, as we talked about with the previous study compared to this study. From the previous study, the most was 13, 14%. This study, the most was 56%. Here's a results summary of percent degradation of gel bricks versus dry ice. So we look at just the very, very minimal effects of gel bricks on the left-hand side and the extreme cases on the right-hand side. And just remember, for this one, we cap off, we have extreme drops on the very bottom, but that isn't the worst degradation for the gel bricks. But these are the comparable numbers. Recommendations. So a thermal shipper should always be validated with the distribution environment in mind. Just remember, when you ship something out with a thermal container, when you ship something out with a cold chain shipment, you're never going to have a pristine package. You're never going to receive any types of drops, vibration, compression. You're shipping through the distribution environment, which means that you're at the mercy of your shipper. You're at the mercy of whoever is shipping your container. And they're not going to typically treat it as gently as we would. And then this is what statement that I always love asking my students, and I love just really talking about. I ask the question of the cost of failure. So when I ask them about packaging, I say, what's the cost of failure? If it's a computer, like somebody doesn't get a computer, yes, they're a little sad for a week, but they'll get a new one. You're not actually affecting human lives. You're not actually affecting people's livelihoods. People will go on. But when we're dealing with vaccines, when you're dealing with anything in the cold chain shipment, you're dealing with human lives at this point. And then when you get your vaccine, you would assume that it's correct and it has been stored in the correct temperature. Same thing what Eric talked about with the glaucoma eye drops. You assume that when you're about to use those eye drops, you're okay with it. However, if it's been exposed, overexposed to temperatures that they're not supposed to be exposed to, the efficacy could go down drastically, or it could just be invalidated and just not even useful at all. So just keep that in mind when designing packages, especially if you're dealing with human lives. Now let's talk about next steps of the study if we were to continue. So one thing that we didn't do is that if you notice that we tested every single variable singly, what that means is that we tested like a 10% dry ice less, and then that was it. We didn't combine minus 10% dry ice with ambient conditions. Same thing with the cut EPS. We just did cut EPS by itself. But what if you did the cut EPS with a 3A or just an ambient pack out with a 3A? Definitely these results would be very interesting. But once you start combining variables and combining environments, I expect the results to be, the degradation results to be actually a lot more drastic. So the 45% we saw from a 3A, that might turn into a 50 or 60% from a 3A, just because of the combined variables. And then right here, I talked about it a lot, but use a dry ice container that doesn't crack. So what we notice is that most of the worst case scenarios with the percentages, all the dry ice containers, all the EPS containers, they just cracked just because there's not that much material. One drop or two drops gives it a nice crack, and then you have dry ice just bleeding out, and you don't have that insulated, you don't have that nice seal anymore. So how can we circumvent that? We could use, probably the way to do that would be to use the EPS containers that's just a little thicker. So when you do a corner drop, when you do a edge drop, it's just going to dent the EPS and not necessarily crack the EPS. We could also evaluate other materials as well in addition to EPS if that method doesn't work. In closing, sorry about that. So just talk a little about San Luis State here. So San Luis State has always had a partnership with Westpac. So the top picture here, we have the owner and founder of Westpac, Herb Schuneman, he actually was my teacher when growing up and going through the program. And here on top, he's just a guest lecturer in one of my classes. And then on bottom, we have the CEO of Westpac, and that's Nora in red. And Nora is the current CEO of Westpac, and she likes to come to San Jose State as well, just to talk to students and give back and just to educate the future students. So extremely thankful for this partnership and looking forward to many, many years to come.
Okay. So it wouldn't be a webinar if we didn't have a bunch of QR codes here. So if you're curious at all about the ICA 7E standard, there's a QR code that'll link you to some information about that particular standard, just to get some more detail about what actually is outlined in that document. And if you're curious about any other questions about, maybe performing the tests with Westpac, with what we can offer with our cold chain simulation studies, this will be a great resource here if you have any questions. Our team is very knowledgeable and can help you, guide you in the right direction. Here's that slide again with our testing capabilities. Hopefully this kind of solidifies what we've spoken about already, the type of testing that we've outlined. Again, I think we've kind of just scratched the surface in this presentation of the services that we offer. So Westpac's been around for coming up on 40 years, which is pretty amazing. We recently opened a third site in Union City, just about 50 minutes up the road from our San Jose location. We also have a San Diego location. Pretty unique thing about Westpac as well is that we're 100% employee owned, which is again pretty unique. I don't think that's too common in different companies that I come across. So that shows obviously and comes through in those pictures the kind of the ownership that everyone feels at this at the company. Okay, if you have any general questions about Westpac and what we can offer, maybe it's not related to cold chain or just kind of in general our services, QR code on the left will lead you in the right direction there. And then of course, if you have any questions about the packaging program or anything for admin, his QR code's to the right there. So we appreciate your time. Thank you, everyone.
Eric, Edmund, thank you for this great and enjoyable presentation. Let's take a few minutes to answer some questions that came in from the audience. Number one, have you considered performing this study with shipments that are palletized? Either way, what would you anticipate the results to be?
I'll take that one. So we thought about doing palletized shipments. And if we're being completely honest, the reason why we veered away from that is because doing anything palletized is going to be extremely expensive, especially for dry ice, just because the sheer amount of dry ice, and I think the amount that we bought was $5 a pound. So this study easily costed us, I think, $1,000 worth of dry ice. So if you look at a palletized study, if you were to replicate that, I would say maybe one pallet would be $1,000. And then we take that and we multiply by 9 cases. It's almost a $10,000 study at that point, just on dry ice materials alone. But but I could probably anticipate the results of doing a palletized study. Number one is that there's definitely not going to have that much degradation, because when you look at any type of palletized testing, the drops are a lot less than a single parcel testing, which means that you won't see the EPS cracking, you won't see that extreme degradation, again, just because the drops are either going to be 6 inches, 8 inches, or 9 inches or 12 inches, with a 12-inch max based on which standard you're testing to. So that is what our take is on palletized shipments. The degradation will be a lot less. If I was a betting person, I would say definitely under 15%.
Great. Next question. Do you think the shape of the dry ice played a big role in the performance?
I don't think the shape will play a big role, simply because we did a case with the dry ice shards. And I don't think it gets any worse than using the dust and the crumble and pretty much the leftovers of the barrel. So if it does play effect, it's probably going to be minimal, 3 to 4%, just like the study showed.
Okay. Is there a reason why you did not test to ASTM D4169?
I'll also take that question. So good question, actually. ASTM D4169, as most packaging professionals know, is industry standard. A lot of companies test ASTM D4169. And the only reason why we didn't do anything to ASTM D4169 is because we just wanted to keep it consistent with ISTA. So we were doing the ISTA 70 profile at the very end, and therefore we decided to keep testing along just within the same realm of the same industry and the same standards of ISTA. No other reason.
Okay. How would the study change if you utilize the 144-hour profile of ISTA 7E?
I can take that one. So the 144-hour profile obviously is a longer duration profile, meaning we ran the 72-hour profile here, the hot profile, in both of our studies over the past couple of years. 144-hour profile, I mean, yeah, we would gather more data, but I think the highest we saw was 70 hours in our control around there, if I'm remembering correctly. So I mean, obviously we're seeing, you know, the samples leaving our threshold, our acceptance criteria, a lot sooner than that. So for now, the 72-hour profiles seem to be appropriate.
Okay, I think we have time for one last question. Why was the winter profile not evaluated?
Oh, that's a good question. I can take that as well. Um, yeah, so like I mentioned earlier in the presentation, we ICA 70 calls out 4 different profiles. 2 of those are more colder environments. The winter profile is what 70 refers to them as. Um, with the hot profile, our line of thinking was more just, hey, let's get results as quick as possible. Let's subject it to more warmer environments, obviously, or we expected the results to pass our threshold quicker, which obviously we saw the results there. It looks like it did. So it's just a matter of time, but something considered down the line for sure. Just to gather more data with more varied cases, that'd be interesting to evaluate for sure.
Okay, well, thank you, Eric and Edmund, and everyone who attended and submitted questions. If your questions did not get answered, we will respond directly by email within a few days. If you missed anything or would like to listen to this webinar again, please go to our website at www.westpac.com, and under the resource webinar tab, we will upload a recording within the next couple of days. Thank you everyone for attending, and we wish you all a terrific day. Thanks. Bye.